And we're back. It's time to sort it out with Mr. Sort Out. Billy on a hill, level 1. Another energy problem. Sledding. So we got Billy and a sled at the top of the hill. We know they're massed together. Then we're given little g, the length of the hill that he's sliding down, the angle of inclination, and then the coefficient of friction, because he's going to slide down with no friction, then encounter a frictional surface this way that will act until he stops. So we want to know his speed at the bottom, and then we want to know the horizontal distance he's going to travel. So let's think about this using energy. So we've got some gravitational potential energy to start. That's going to equal his kinetic energy at the bottom. Then plug in and rearrange. Here we want velocity at the bottom of the hill. So notice that the mass cancels out. And in this expression, it's delta y that we're looking for. So that's not the same as this. Draw the triangle. That's the distance that he goes along the hill, but the vertical change in vertical height is what is going to determine the energy change. So draw the triangle, and so this is a way that how you would use trigonometry to find the change in height. So use that as your delta y. Then the second part of the motion is down here. We're on their frictional surface, so we want to know how long it's going to take to stop. So let's use the work energy theorem for this one. He's going to have kinetic energy to start. He's going to have zero kinetic energy at the end. So the amount of work that's done on him is going to be equal to that kinetic energy he has to start. So if we write it like this is the work done by friction. It's the force of friction times the distance. And remember, that's going to be negative because he starts out with energy, and then in the final state he's going to have zero. So the change in kinetic energy is negative. So then plug in what we know for force of friction, mu times normal force, and then the distance it takes him to stop, I'm calling that d2. Then kinetic energy initial we can put right there. Then simplify, rearrange a little bit. So notice that the negatives cancel, and then the mass cancels as well. And so this will give us the distance it will take him to stop based on his initial velocity. So that's what we need for that one.